the opening of the Green New Deal, which talks about the damages economically and environmentally that will come as a result of climate change, of the 1.5 degree increase if we don't do anything, right? And it might not come as no surprise because I think we've been critical of models on past episodes, but what I look at this now after going through the models, after seeing how models shape the decisions around COVID, and it just compiles with my even before that, even before COVID models and how they are used to shape the political decisions. I worry. So I worry here that, again, we're looking at terrible exaggerations with uncertainties on these numbers that aren't explicitly talked about here. And so again, we got this goes back to like these reports are fueling the eco anxiety that the Greta Nation is going through, right? And I just, if you think about how off models can be, this is irresponsible in some regards to, and anyways, I haven't personally gone through the model, and I think it's a beast to go through the model of that institution and that, that panel and what they're using to even get it. But I look at that with a very suspicious eye and come at that angle. Now, it's not to say that I don't believe in climate change, and I want to actually speak a little bit about my thoughts on climate change because I don't think we've really delved that deep into it on the show. So in a brief summary of my thoughts, I wanted to start by talking about something that we learned early, but I'll reiterate it here in a general sense. So I wanted to just talk about the volume of gases in dry air, okay? So in dry air, we have about 78% nitrogen, 21% oxygen, and about 0.9 argon, okay? So what's left? And these are rough numbers, but there's a little 0.1% there that is a mix of other gases. And in that 0.1% is our CO2. And immediately, I think anybody who hears those numbers goes, but aren't we putting all the CO2 into the atmosphere? Like, what the hell, And this is the problem. And here's what I want people to think about, okay? So that's dry air. So here's another thing to throw in. Before I get back to the CO2, let's talk about air is not dry. Most of the time, it's filled with humidity. And that's water vapor is one of those greenhouse gases that people just kind of ignore, but it's there because it's kind of like this thing that the water cycle happens in the background, right? But, effectively, humidity in air acts as a greenhouse gas in a sense and plays a role. But this is constantly changing with time and altitude in our atmosphere. And so when we look at the carbon too, it's a small layer, but it's kind of like the e-coating that you can get on a window. So you have like a window, two pane pieces of glass, okay? It only has like an insulation of, for anybody who knows how insulation goes, there's you have an R value of 2, and the lower the R value, the less insulative it is. You put a small, less than a hair thickness layer of e-coating on that frame, and suddenly that can jump up to a 4 or 5. It can double. So it's not obvious by the volume amount of CO2 that its effect is proportional. A small layer has a magnifying proportional impact. So, and a lot of these things happen in environmental systems. So yeah, and do we still not understand fully how the carbon cycle works? No, we don't. And I was reading actually recently up on these satellites. So there's a couple missions, and NASA's doing the OCO2 and OCO3 that are like measuring in real time carbon concentrations in the atmosphere and how they are distributed across the world. And that Japan's doing something similar with the GOSAT. And we're still learning a lot about where this carbon layer is thickest and highest in concentration and what parts of land are. Because the other thing is, we have this huge dynamic system of wind patterns all across our atmosphere that have, in some senses, generally predictable directions, but there's also all this mixing that happens, and so it's a very complex, even to model it's very complex because the computation power is just so vast. And then the other thing I wanted to say about carbon dioxide, which a lot of people who know that, who have done any environmental research know that once it gets into the atmosphere, it can last for 300 to 1,000 years up there. So my question is, I've kind of, between my, schooling, my research now, my opinion is, okay, climate change is happening. Climate change is happening for two reasons. There is a climate change that happens that predates man, that is in the background here in my head. But then there is, man is impacting. To the degree I'm not too sure, but it doesn't even seem conceivable to me that you can have 7.7 billion people on this planet, and when you look at the industrial scale we're doing things, and you look at how subtle shifts can cause massive change on environmental systems, that we are not doing anything. I think we're doing, actually, I would I'm just speculating here, but I think you could say it's within a range that's higher than 50% of our impact right now, in compare with the other percentage basically being made up by these other natural climate movements that are changing. So yeah, I'm not a climate change denier, is I guess the point that I want to publicly put out here. And there's still lots to learn here. And I just wanted to caution there about models and the numbers.
Yeah, I think it's important to note that models are, what is the definition of a model? A model is trying to recreate the real world. Keyword trying to, which means that it's not actually the real world. So we always have to be mindful that the model that we see, that we're estimating, is trying to recreate the world, but that's based on a set of inputs, a set of assumptions that aren't always accurate and are generally not accurate, actually, as a matter of fact. So when we have these models, we always have to remember that there's error bars associated with them, that these numbers of 1.5 degrees Celsius, this is not an absolute, because that would imply that your model is absolutely 100% accurate, which is, I can say absolutely 100% not true. Because I have looked at these models, I understand what comprises them, and I understand that the level of uncertainty within them is extremely high. That's when we have these absolute numbers that are given to us. Oh, we have 10 years for 1.5 degrees Celsius. It's like these exact numbers are fables. They're not. They're myths. And the more and more that you try to purvey them as absolute truths, the more you lose people again in the conversation, because people know people aren't stupid. People realize models aren't 100% accurate. People realize that your model especially isn't 100% accurate, and for you to be touting it as being so 100% exact, and people just tune out, and they don't have very much interest in having a conversation with somebody that's being disingenuous ultimately.
Right, because I feel like the more we see models used, get it wrong, but have people in power making decisions off them and not admitting that they were wrong or they made a mistake, the more models will become like the boy that cried wolf. And every time somebody hears about some model did this, everybody's going to be like, gee, you lost
People
me.
are going to roll their eyes.
Yeah.